Okay, so this particular part is about power functions, which have an exponent. And you can see up in the top left corner, they gave you a few power functions, some of which you are very familiar with. Some of them you might not be quite as familiar with. But a power function is a function of the form f of x equals a times x to the b, which if you remember yesterday in the middle of the page, they made us put things in that form. And sometimes when we did, we got negative exponents and stuff, and I was like, it's okay for the purposes of this. That's because if it's a power function, sometimes the exponent is negative. Your final answer won't have a negative exponent, but you use it to process. So over here you can see these are exactly in this form. A and B have to be real, non-zero numbers. So let's look at this one first. That's kind of like the one we were just doing a minute ago. Something about weight and the radius of your distance from the center of something. This number in front, that's your A value. Your A value is 320. That is a real non-zero number. Your B value is the exponent. It is also a real non-zero number. This one right here is the volume of a sphere. So this is the formula for volume of a sphere. That first number, 0.0939, that is a real non-zero number. And the exponent 1.5 is also a real non-zero number. Now this one, you are very familiar with. What is that?
That's an
area of a
circle.
Pi. Now this one sometimes it gets us because we look at pi and we think that that's a variable. But it's not. Pi is a real non-zero number. It's 3.14159, blah, 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 blah. So it's a real non-zero number, and squared is a real non-zero number. So they're all what we call power functions. So what they want us to do is put these into power function form. So we're going to put them in a times x to the b power, just like we did yesterday, and then identify the a and the b. So for this first one, I'm going to rewrite this stuff inside the parentheses as x to the 2/3 power. Remember, the number from the crack goes on bottom. So that would make my a value 7.4 and my b value 2/3. Alright, number 2, same thing. We want to write it in a times b to the x power form. So in this case, my x is on bottom. It's right now it's in a rational sort of form, and I don't want that x on bottom. I need it to be up next to the 9. So when I rewrite it, I'm going to rewrite it as 9 x to the negative 1. So your a value is 9. And your b value is negative 1.
So even though like that one's not a power function, because it's the b is negative numbers.
It just has to be real and non-zero. It can be negative. For power functions, it can be negative. Okay, so in number 3, first thing I would do is take care of the fact that 64 is a perfect square. So I would first, I'm going to do this part right here. This is really 8 times square root x. So now to rewrite it as a power function, that would be 8 x to the 1/2. So your a value is 8, and your b value is 1/2. Okay, now in this one I'm going to rewriting to friend. So I'm going to rewrite first 6/4. 6/4 simplifies. So do that first. And then I got to take care of the fact that I got x's in both places. So let's take these guys, move them upstairs. What happens to them when I move them upstairs? They get really unhappy, right? So that's x to the negative 5. There's one x up there and it's positive 1. Now I just added negative 5 to it. So what do you get in the end? Yeah, to the negative 4. So I got 3/2 x to the negative 4. That is in power function form. your A value will be 3/2, your B value will be -4. So that's kind of what we did yesterday. Now on 5, you're going to combine what you just did with variation with what we did yesterday. So number 5, we got the pendulum, the period of a pendulum, or the length required to make one complete pendulum swing, varies directly as the square root of its length. So first thing you got to do is set up your formula. So do that, and then we'll plug in. Yes, ma'am. How are you?
Cool. R Q to VAP.
Yes,
You gonna send them over to me?
I can.
Okay. And we'll put you in the email list so she can send out the minor stuff and I'll be out there for you.
Okay.
John create this for your cover, we get to have
Okay, yeah, that's fine. I didn't even think about that, but yes, I can send it.
Thank you.
Yes, sir.
So we just change,
So this will, let's see, this is gonna be P equals K
Square root x.
square root X.
So you just change it to P,
So,
K, 1/2 x to 1/2.
uh-huh. Well, we can actually find our K, right, because they gave me my P. So, the length is, okay, so 0.5 is the period equals K times 25 to the 1/2. So K is 0.1? Okay, so now when I go back to rewrite it, because I have, here's how I had it written. I calculated and found my K to be 0.1. So now I'm going to go back and rewrite it as P equals 0.1 square root X, or because they want it written as a power function, P equals 0.1 X to the 1/2. And then you can plug in your new X value. And when you plug it in your calculator, by the way, you don't have to put the square root, you can raise it to the 1/2 power in your calculator, it does it just fine. So this would be P equals 0.1 times 100 to the 1/2 power. Which equals 1 second. All right, is everybody okay? So you should be good through, go ahead and do 6, 7, 8, no, I think you should be good through maybe the whole thing. Let me look real quick, make sure I'm not missing something. Are these due at the end of the year? No, not until tomorrow.
Can we turn the variation in then?
Yes, turn the variation one in.
That's not good. I sent it. Yeah. Anybody else variation when we turn it?
So 6 is just normal then, obviously? Because it doesn't say anything about us.
Yeah, it just says varies inversely, yep, so it's just Kx, K over X. Actually, this says for y'all just to do through 10. And then I guess tomorrow we'll do 11 and 12 together. I don't know what's different about 11 and 12, but we'll see.
So do you still want to go?
Actually, no, y'all go ahead and go through 12, it's fine. What they want to go through.
Are you still wanting to go to OAP, Jody? Okay.
Yes.
Okay.
These are just
Yes.